Next, please welcome Sarah Zieman from the Civil Engineering Program in the College of Science and Engineering.
Katy Perry once said, "Do you ever feel like a plastic bag drifting through the wind, breaking into microplastics?" Okay, maybe she didn't say that last part, but I bet your ears perked up at the term microplastics. There's a growing public health concern about how toxic and how widespread these particles are. But it can be difficult and labor-intensive to measure the size, type, and presence of microplastics in all of our ecosystems. Nanoplastics, which are even smaller than microplastics, pose more serious problems, as they can be ingested more easily and they are more challenging to detect. My research focuses on how micro and nanoplastics are generated from the breakdown of our large plastic products, which is necessary to understand how much plastic we are being exposed to and how toxic it could potentially be. I am taking a data-driven approach to compile nearly 300 studies on plastic degradation in the natural environment. My analysis can inform a risk assessment, which can help us to mitigate our colossal plastic waste problem. See, the thing is, unlike other pollutants, plastic degrades in a multi-step and multi-phase reaction. So there are different types of measurements to study a plastic's breakdown. So far, I found that both the type of plastic and the environment that it's in can be important predictors in how and how quickly a plastic will degrade into further products. This can help us to understand how, why, when, and where micro and nanoplastics exist in nature, which then can allow us to make smarter choices initially about the plastics that we use. As of today, there is a lack of data and understanding in specifically how mechanical forces degrade plastic in the environment. For my next step, I address this gap by focusing on one mechanical degradation mechanism called abrasive wear. This happens when hard sand slides against plastic, which occurs widely in beaches, riverbeds, and desert environments. We simulated these interactions in the lab by creating a custom sand abrasion device. Surprisingly, we found that the plastic film strictly released nano-sized particles, and there were nanoplastics stuck to the sand. In the environment, the plastic-coated sand could be washed downstream or blown by the wind, and further distribute these nanoplastics in new environments. This plastic-coated sand could also interact with other known harmful pollutants, like heavy metals or pesticides. My research on a plastic bag drifting through the wind may not be sung to a catchy tune like the Katy Perry song, but it will help us to better understand how our plastic products are changing human health and impacting the environment. Thank you.